Hello, I'm Williams to go on this EmoHydra, multimodal motion classification using heterogeneous modality fusion. This was originally set to be a tech demo, but the window lags every time a prediction is made and needs to be displayed asynchronously to the remaining processes. We succeed in real-time inferencing as we can handle a full inference every 0.4 seconds, and we have not tried to optimize this as of yet. This includes the pre-processing as well as the inferencing of the model on real data. Our three top models are trained on large quantities of open source data. After augmentation, this comes out to be over 2 million samples. And we use MELD as our multimodal data set for adapting our features. Came from our long training runs on single modal data to become a multimodal model to further balance how our fusion layers or our multi-head attention layer weights each feature or logits towards giving one prediction. We created a simple version of this concept called EmoChimera, which simply concatenates the model outputs from our three top models and then remapping the labels so that they align. It happens to be that this method does not actually work. We find that despite high performance on single modal data, this does not necessarily transfer over to multimodal data. For EmoHydra, we use both the fusion layer, which takes in logits as input, and multi-head attention layer, which takes in features from all three networks. For real-time inferencing, we use OpenAI's Whisper model, and we use Ultra Analytics You-Look Only Once model. We were able to confirm that our architecture is fast enough to work in real time, so our focus is now optimizing the classification accuracy of the model. So for MELD, the pre-processing involves taking the video and taking the faces over the entire sequence over a certain interval and capturing using YOLO every single face in that frame. For our model, we need to pass this in as a batch, so we can form this as the summation of all faces over that time frame over the full interval. And this goes with our single text input and our single audio input, which is MFCC. This fully captures the temporalness of a certain environment without necessarily needing to pass direct video input into the model for a facial recognition model. And this really helps because it is not only still accurate, but we don't have to worry about increased dimensionality or other imbalances